Okay, so lesson 1-6, I think I'm just going to talk through a filled out notes page because we did this a lot in trig and we've talked a lot about it. So this ought again be a pretty easy lesson. So we talked about like if you have a quadratic, if you stick a negative in front of it, that reflects it over the x-axis. If you think about the sine graph, so 2 sine x made the graph taller, but sticking the 2 inside there made the period, so it affected putting the 2 inside there. Putting the 2 inside there affected it horizontally. It meant the period was just pi, but putting the 2 in front of there affected the graph like it made it taller. So that's exactly here. So that's considered a vertical stretch. All right, and so we have the absolute value reflected, vertical stretch of 4, and then the negative is gonna reflect it, and the half is gonna make it wide. So and I wrote this down, I'm not sure if it's on your notes page or not, but if you stick the negative on the inside, that's going to reflect it over the y-axis. And we didn't do any of that in Algebra 1 Honors, and you should have done a little bit of it. You should have done that in Honors Algebra 2, but sticking the number on the inside reflects it over the y-axis, and sticking the number, what I call inside the house, does the same thing. Like sticking the 2 right there affected the horizontal component of the sine graph. So sticking the 4 inside, it is a horizontal. Okay, so here we have a cube. So we have a cube, and then again, sticking the number inside the house, moved it 2 to the left. Inside the house, moved it 3 to the right. So we had that conversation. So this page, like if the number's on the inside, I call it inside of the house, then it's the left and right guy. But then down here, if it's outside of the house, that moved the graph 3 up. That moved the graph 3 down. That moved the graph 1 to the right. And then the negative reflects it over the x-axis because the negative's on the outside. All right, I really love these. So when the number's on the outside, remember, it affects, like 2 sine x makes the graph 2 taller. So that's why you're going to take every y value and you're going to make it 2 taller. So this was the original one, and then every y value got multiplied by 2. That 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 y value got multiplied by 2. But if you stick the 2 on the inside, remember that made it, that affects it horizontally. So you are going to multiply the x's by a half, which is to say dividing by 2. So you're going to take every x value. So I took that x value, divided it by 2. Took that x value, divided it by 2. I took that x value and divided it by 2. So this guy right here, so this guy, the black guy, was the original guy, and the guy that I just did in red is the shift. So the negative on the outside reflects it over the x-axis. So the black guy is the original guy, and then that's me reflecting it over. When I stick the negative on the inside, that reflected it over the y-axis. I don't know where the original guy is here. Hard for me to tell. I'm going to say that maybe that this guy was the original. It's actually kind of hard for me to tell what the original was, but you reflect it over the y-axis. So if the number's in front, remember that affects like how tall the sine graph is. So like you're going to do all the y values get multiplied by a half. But if the number's on the inside, that's going to affect the x values. So you have to divide it by 1/2, which is of course the same thing as timesing by 2. So the original guy I'll keep in black, and then the guy where I multiplied all the x values by 2, I put in red. So this is where I moved this guy 1 to the left. And then this is where I took all the y values and multiplied them by -2. So here were the original points. And then I took all the y values and I multiplied them by 2. And then I graphed them. And so that's all there is to 1/6. I think that'll be a pretty easy lesson for y'all.